Hi everyone, welcome back to my channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSS sheet, and in this we were doing array topics. Inside it we were doing the cadence algorithm patterns, and today we will do the next problem, which is maximum product subarray. So let's read the problem statement. It says we will be given an integer array nums and we have to find a subarray that has the largest product and return that product. The test cases are generated so that answer will be fit in 32-bit integer. Means it is saying ki the integers are managed in such a way, like test cases are generated in such a way ki it can be managed in 32-bit integer. So it means ki we don't have to take the long variable data type to store our product answer, because sometimes it might happen ki when we will multiply multiple numbers, it might go beyond 32-bit integer where you have to store in long instead of int. So here you are free to use the int only instead of long. Now let's read the constraint. It says num's length can be 2 into 10 power 4. Okay, so if n is 2 into 10 power 4, so n square will become 4 into 10 power 8, and you know beyond 10 power 8 it might give TLE or else it will be very slow. So hence we need to optimize it here. Okay, and let's see the nums of I. Nums of I value can be from minus 10 to plus 10, means integer values can be negative also. And why do we read this? Because it helps us to identify which pattern to apply while optimizing it. Okay, so we know that we have to return that subarray whose product will be maximum. So as we have negative number also here, so you know one negative product will make the whole product negative, but when we found two such negative numbers, then their product will become positive. So what will be the brute force approach here? It says find that subarray which has maximum product. So if you know how to print subarray, then this question is very easy, because if we can find all multiple subarrays, then out of all subarrays we will keep on multiplying it and getting the products, and out of all we will check it ki what is the maximum product. Yes, we can do. So what I said ki we will start running our I loop from 0 index, because when we want to print all subarrays, that's how we start, right? Now we will start the j loop from the same ith index. Okay, now I keep standing at 0 position and j will start running from 0 to last index. And how it will print? So j will take care of all such subarrays which starts with ith index. Okay, so when I is 0, j is 0, it will give one subarray which is 2, and product is also 2. Okay, so it will give 2. Now it will give, next time it will be 2 and 3, so product will be 6. Yes, now next time 2, 3 and minus 2, so product will be minus 12. Now next time 2, 3, minus 2 and 4, and what will be the product? Product will be 48 but in minus. Okay, now next time we will move this ith index to next one, and j will start from the same location of I. So now this time we will have all the subarrays starting from I is equal to first index. So now first time it will be 3, product will be 3, next time 3 minus 2, product will be minus 6, and next time 3 minus 2 and 4, and the product will be minus 24, and so on. Similarly, next time this I will be moved forward and j will again restart from the ith index, and now we will get all such subarrays which starts with I is equal to 2. And that's how we will run all such subarrays, get the product, and out of that we will get the maximum one. Okay, so I think we can write the code for this. Yes, how do we write? Let's see. So I want to take care of a maximum answer all the time. So I want to initialize my max variable which will take care of my maximum answer, and I will initialize with 0 or minus 1. What do you think? So we can initialize with minus infinity also. Why minus infinity? Because we know ki numbers are from minus 10 to plus 10. So we have to initialize with number less than minus 10 or equal to minus 10. So we can initialize with minus infinity also, and to be more precise, we can initialize this with minus 10. Why I am saying this? Because it says the number can be from minus 10. So what if in the worst case it will have only one number, means one product minus 10. The maximum product will be minus 10 also, correct? Yes. But what if minus 10 and minus 10? Okay, so first time we will have minus 10, next time we will have 100 now, because minus 10 multiplied by minus 10, it will become plus 100, and in that case minus 10 we won't be the maximum answer, correct? So hence initializing the maximum answer with minus 10 will be safer here. Now we want to run the two for loops to get all the subarrays. So we will start with for int I is equal to 0, and we want to run till nums.length, let's say n and I plus plus. Okay, now we want product of all such subarrays, and all subarrays is taken care by j loop, correct? So we will start for int j is equal to, we want to start j from ith location, we want this to go till n and j plus plus. And as j loop is creating all such subarrays and we want the product of that, so hence we will initialize our prod variable from here and we will initialize with 1, because you know when we add something, summations would be initialized with 0, but when we multiply something, if we will initialize with 0, the whole product will become 0, so hence we have to initialize with 1. Okay, now what we will do, we will multiply nums of j in our prod. Why? Because j is here, suppose at 0 location, so prod will have nums of j. Okay, next time prod will have nums of like previous j also and this current j after incrementing j plus plus. Yes, yes. So now if you have multiplied this prod, okay, so 2 is there in the prod, so don't you think instead of multiplying the another number, you should first check if this is maximum or not? Yes, yes, you have to. So what we will do, max answer is equal to math.max, maximum answer till now is maximum or this prod is maximum, whatever is maximum it will get updated, correct? Now after coming out of this 2 for loops, we can simply return our max answer. Yes, and this will give you the maximum subarray out of all. Now let's see the time complexity here. As we are running the 2 for loops, 2 nested for loops, and for every ith for loop, j is running for somehow n times. Why I said somehow? Because when I is here, okay, j is starting from the same ith location. So for first I, j is running for n minus 1 time. Second time j is running for from I 1 to n minus 1. So total n minus 2. Next time n minus 3. Next time n minus 4. So in total n minus 1, n minus 2, n minus 3. Similarly, somehow nearby to n only. So O of n multiplied by O of n will give you O of n square time complexity. So here we have initialized nums.length and maximum product we have initialized with minus 10. Remember, you can initialize with minus 10 to minus infinity, all are safe. Now we will run the for loop for I from 0 to n and we will initialize the product. J we will run from I to n. Again we will multiply this nums of j in product, and after multiplying we have to check what is the maximum product till now, and after coming out we will return. So let's run this, and as you can see it has been passed, and now let's submit this. When we will submit, we might see that this will be very slow. See, the time complexity is O of n square, so the code is very slow. So hence, whenever the code is slow or TLE, we always opt for optimization. And you know, whenever we want to optimize, we have learned 4 different patterns in arrays. And what were those? Those were 2 pointers, prefix sum, sliding window, and cadence algorithm. And all these 4 patterns we have already discussed in very depth in the very first video of our playlist. If you have not checked it out, I will definitely recommend you all to go and check that video first. Now let's see, 2 pointer we apply whenever the array is sorted, and we can decide कि these 2 points, which point will move ahead towards each other, left or right. And one more thing, when we want only those 2 numbers, exactly those 2 numbers and nothing in between, okay, then 2 pointers works. But here we are looking for subarray, so hence we cannot apply 2 pointers concept. Second one is sliding window. Sliding window we can apply whenever we want subarray sum or product or anything. But remember, all numbers should be positive. If there are any number negative, then we cannot apply sliding window. So hence here the number is negative, so sliding window also fails. Now let's come for prefix sum. Prefix sum we apply whenever we have to talk about subarray sum or product, but in multiple times, you know, like to answer multiple queries. Number can be negative also, positive also. Okay, so hence we can think of prefix sum. Now fourth one is cadence algorithm. Cadence algorithm help us to calculate the maximum summation when negative number occurs. How? By reinitializing the summation from negative number to 0 again. Okay, but this is a concept. In product we can think of reinitializing again. Yes, but now here 2 patterns. Prefix sum also we can apply, cadence algo also we can apply. So let's see what we can apply here. Okay, in this question we can apply both, but cadence algorithm is a kind of state DP. Okay, and in this question, because the negative number is there, why I am saying, suppose negative minus 2, 3, 4 and minus 1 is there. Okay, and you have to calculate the maximum product in just one go. One go means O of n. Why? Because we are optimizing it here. Yes. So if we will consider this minus 2, the answer will be minus 2. Yes. Then we will move to this one. Answer will be minus 6. and so on. So you might think it is negative number, then why to keep? So you would like to leave this 2, correct? You would like to leave this 2 because this is 2 is negative, okay? And you will start with 3, correct? As per the basic cadence algorithm. You will start multiplying 3 into 4, so total 12, okay? But now you found -1, again you will leave it. But don't you think if you would have taken -2 also and -1 also, -2 also and -1 also, then total multiplication would have become plus 24, which is far greater than 12. Yes, it is. So hence I just want to say in cadence algorithm, whenever we found any negative number, we still have a choice ki we can take it, pick it up also, and we can not pick it up also, correct? If here you see, if you would have picked it up, you would have got the greater number, and suppose -1 was not there. So if you would have picked it up, then obviously total number will be -12, and that is not greater number. So hence in negative multiplication case, you are not sure. So here when you move forward, you take both in variables, took and not took, kind of, okay? So means we are talking about state DP, and in this video we will not cover this state DP concept because we have learnt only arrays and its patterns till now and not dynamic programming. So hence for that we will cover that topic in the next video ki how we can solve the same problem with the cadence algorithm, which is a state DP. Now another optimization technique which we can apply here is prefix sum, prefix and suffix concept. How? Let's see. So I am saying start from this end. First you will get 2. Okay, it is maximum till now, then 2, 3, okay, 6 is maximum till now. Now -2, no, it is not maximum, it's okay. Now 4, no, it is not maximum, okay. So when you move from this side, you found 6 maximum, correct? Yes, but what if one more number were there? So from prefix side, like from starting to, you have not found this 8 product, na, because you have taken this minus also. Yes, so that is why one more time we will run, and we will run from the last end. Now this time what we will do, if suppose 2 is there, so we will run this. So 2 is a maximum product. Now 2 into 4, 8 is a maximum product. Now -2 also comes, so -16, no, it's not maximum. Now -16 into 3, now -16 into 3 into 2, no. So from this side we found 4 to 8 maximum, and if we have run for prefix, this would have given me 6 maximum. So out of all, whatever is maximum we can calculate. Very simple. Yes, but there is one more concept. What if in the number we found a 0 in between? 2, 4, okay, kind of 2, 4. So if you will start from there, think again. 2 into 3, 6 you will find. First you will find 2, now 2 into 3, now -2, now into 4. So total till now negative number, and 6 only maximum, which was because of 2 and 3. Now the moment you hit this 0 now, the whole product will become 0, correct? Whether it is negative or positive, and we don't want that. So whenever we hit 0, don't you think we have to start again from here? Because if we will take this 0 forward, then every number will become 0 now. 0 multiplied by 2, 0 multiplied by 4 and all. But we don't want to take it. So hence whenever we found 0, instead of bringing the previous prefix sum, we will again start our prefix product from 1. Okay, so 1 into 2, again 2 and then 4. So from prefix side also we have found 8. Okay, and from suffix side also we have found 8 as a maximum. Then we found 0, so hence we will initialize our suffix from this side, suffix product. So suffix product from 1 and then 1 into 4, 4. Okay, so this is a basic idea of prefix suffix concept, which will also give us a solution in O of n time complexity. So hence you can see that we have initialized a prefix product and suffix product with 1 because it is a multiplication, so we cannot initialize with 0. Now we have to, at every step we have to check what is the maximum, so hence we will initialize with -infinity also or -10 also, both works. Okay, now we will calculate the nums dot length, and we want to run a for loop from 0 to nth index, correct? Now for prefix and suffix we could have run the 2 different for loops, okay, but we can do using the single for loop as well. How? Let's see. So when we are running this for loop, first we will check if the prefix product, like prefix product is 0, like multiplying any number, it has become 0. Then we want to reinitialize our prefix product and similarly our suffix product, correct? After that we will multiply this, like nums of I we want to multiply in prefix. But if we want to multiply suffix, so let's come here. I want to multiply this, so nums of I is this. So in prefix I want to multiply this, correct? At the same time in suffix I can multiply this also, na? Like obviously we will run for n times. So in prefix, when we were multiplying this, suffix will multiply this. Now next time prefix, when it multiply this, suffix will multiply this. Now in prefix, when it will multiply this, suffix will multiply this. Now in prefix, this will be multiplied and suffix will multiply this. So instead of running this 2 for loops which will make O of 2n, although it will be fast only, but when we can do in a single for loop, why not to do so? Okay, so when we are at this I is equal to 0, we want our suffix to be multiplied with this index value. And what is this index value? If you will see 0, 1, 2, 3, correct? And if you will see n is equal to 4, so what I want n minus I minus 1. Why? Because for first time I is 0, so it will give 4 minus 0 minus 1, which is 3 only. Okay, now next time when I will be 1, so n minus I minus 1 will be 4 minus 1 minus 1, which is 2. Obviously I want to stay here for suffix, correct? So hence if you will see here, that's what we did. Prefix multiplied is equal to nums of I, and suffix multiply is equal to nums of n minus I minus 1, which is similar only. And after calculation, like at every iteration, we want to check ki prefix is maximum, suffix is maximum, or our previous calculated answer is maximum. Okay, so that's what we do, and at the end we will simply return our answer. So if you run this code, everything will pass, and let's submit this, and that is far better and optimized solution. And you can see 90%, and this is the fastest solution. Okay, so this was a Java code, and this is a Python code if you are from Python background with the same logic, and here is your C++ code with the similar logic. If you would have understood the logic, definitely no matter from which coding background you are, you can do it on your own. So with this, we can go in our sheet and we can mark the second question, which is maximum product subarray. So I hope you guys are doing along with me. If yes, do let me know in the comment section by commenting understood or solved, so that I will also get to know you guys are solving along with me. And definitely guys, if you are new to this channel, we are following this Rising Brain pattern wise DSA sheet. The links you can get from the description, and if you want to connect with me on any social media, all the connection links will be there in the description. You can check it out and do reach out to me if you want any kind of guidance. And that's it. I hope this video was helpful. If it was, please do like and comment, and you can share with your friends as well. And I just want one thing from you all. If you are watching this video and if you think after watching it, if you understood, then you are done, no, trust me, close the window, close the notes and all, and try writing the code on your own. If you can write the code on your own, then only you can think yes, you understood. And after one time, it is not guaranteed you will remember this. So for sure, once in a week, I would definitely recommend you all to sit with your notes and do the proper revision, because DSA is something which you might understood in 1 or 2 go, but you cannot remember forever if you can't revise it. So that's it for the day. Let's meet in another video with some more interesting questions and topics. So then keep learning, take care of yourself and your family too.